What we're going to be talking about today is a little bit, just very briefly, who we are, who Magic Leap is, in case you have not heard of Magic Leap, what it is that we do, what does mixed reality mean, and how do we actually develop on our platform. And this is where we're going to be digging a lot more into more of the gameplay and AI side of things, and then we'll finish off a little bit about why we're really excited about working on this medium. So my name is Aleissia Laidacker. I am Interaction Director for our West Coast studios at Magic Leap. I've been there for a little over a year. Our offices focus a lot on building developer tools for the platform, as well as samples and content for Magic Leap. Before that, I worked in video games for many, many years. I was at Ubisoft Montreal for 11 years, where I was lead gameplay AI programmer on all the Assassin's Creed games. At the beginning, I was very focused on character behavior and trying to make it so that Ezio and the assassins look super believable. And then I transitioned more into crowd AI and how to develop large-scale systemic systems, yes, for crowds. I am also very obsessed with anything that is immersive experience design, so Sleep No More, location-based experiences, and I think it's really exciting to be working on a medium where it's not just building games and experiences that are on a screen, but also for developing something in the real life around us.
Hey, my name is Brian. I also came from the game industry for a million years. My first game was actually on the Sega Genesis, believe it or not. I've done just about all the genres you can think of. Last game, I worked at Blizzard on the Hearthstone game. I was the lead AI and gameplay person for that game. And then I decided to jump into the wonderful world of startup Crazyland. And so I ended up at Magic Leap, and I run the Interaction Lab, which is a rapid prototyping group in Florida, where we try to take all of the new features of this crazy hardware that we're building and test it out, give feedback, and explore what we can do with it. And so that's why we're here today. So who the heck is Magic Leap? Our mission statement, if you like mission statements, is that we harmonize people and technology to create a better, more unified world. I like that because it's very simple. It doesn't have a lot of crazy fluff, really. And to me, like, the medium that we're pushing into, mixed reality, this is what we're talking about, right? We're trying to bring pixels and put them wherever you want them. We're trying to make it so that you have access to compute and display wherever you are, whenever. So, but I have actually been at Magic Leap for about 4 years, and I've been there from the very early days. And so if you see, this is one of our earliest pieces of prototype hardware, and this thing was called the Beast, and it's basically a large optometry device. This thing right here is the thing that you put your chin on so that you can stare forward, exactly as if you were at the optometry's office. Very quickly, though, we started miniaturizing the optics, trying to get it to be on a wearable form factor, and fairly quickly we even got it to a much more mobile device that we used this as a dev kit for a number of years. Like, this says prototype hardware 2015, but we were still using it almost all the way up until the middle of 2016. So you can see, like, in the 2016, I'm wearing it right there, but in very early 2017, I'm already wearing the new form factor device, which we call the PEQ, a product equivalent. So that has gone through a number of iterations itself, but you can see, like, an early tagging as to which particular model this PEQ was. But so in very, very quick number of years, we managed to miniaturize all the optics and everything and get it into a semi-decent, comfortable form factor. And so we're excited about it.
So we're at this point now where this is what our form factor looks like. We've announced we are releasing this year, but we have all these sensors, and I guess, like, for us, why we're here is to tell you what it is that you can actually do with all of it. So we actually, right before the talk, someone was talking to us about, oh, do you think that mixed reality is going to take over where VR has started? And our answer is always no. Like, VR is there for one specific need, AR is there for something, and mixed reality does something that's very different. VR really is where you put the headset on and it shuts out the real world around you. It's really about escapism. If you want to jump into a story that's been told where you go to this digital, beautiful world, then that's where VR really does make sense. Now, AR, we've seen the beginning stages of things, like anyone who's played Pokemon or who has even tried Snapchat, that's where we're using AR every day in our lives. But AR right now, especially like on the Pokemon side, you've got this digital character that I can see through the AR camera, but that digital character has no awareness of the world around me, and that real world has no clue that there's supposed to be this digital Pokemon character there either. What we're doing with spatial computing is where we actually get full information about the world around me. From the chairs that are there to you who is sitting there and nodding your head at me, I could get all of this information. And the idea with mixed reality is to really have digital content that purely interacts with the real world around you. This was an old concept art from a game jam that had been done at Magic Leap, and I still find this is my favorite example, where you actually see that they had built this set using toilet paper rolls, and it really is where the cats are aware of the toilet paper rolls and they can run through them, and this is really where it's a true mixture of the digital and the physical together.
But we do understand that there is kind of like a confusion in the term mixed reality. We've heard several hundred different definitions over the last few years, and I wanted to kind of dive into why I think there's a little bit of a confusion there and why it's sort of a strange issue. So like, when you are thinking about like VR or a screen-based experience, you're getting the full vision that a creator is giving you. He's making a massive, or she is making a massive, immersive, beautiful, extra world. It is their vision of the world, and that's what you get. You get everything. You get this wonderful piece of art, if you will. But what we're doing now is almost exactly the opposite. Instead, what you're doing is making things that are so real they look like they fit into this world, this reality. They're coming out here. Instead of compellingly pulling you into the experience, they're bringing the experience and pulling it out into your reality. And we do have some examples of mixed reality in popular culture, like Who Framed Roger Rabbit, or there was an old Paula Abdul video, or a number of different things where you see, quote-unquote animated or digital or whatever objects out here in the real world, and it's always a fun thing. But it's a very, very different design space, and it's a very, very different thing for people to consume the content as well. I mean, it's one thing to go to the theater and see a rich world and a rich story that's, it's shot well, it's well-paced, it's got amazing actors, and they're telling you a story in exactly the way in which the director wants it to be seen. And it's quite another if you go into your kitchen and George Clooney is there, and he's talking with you, and he's interacting with you, right? Like, that's a very different thing. It's a very different thing to consume as an end user, and it's also a very, very different thing to create as a developer. And the thing is like, what we're talking about is a blurring of lines between how I consume my digital content. Like in the past, I would sit down at a screen and I knew the bounds of the digital world, right? Like they were right here. Or if I put a VR helmet on, I'm kind of in that space. The bounds of it is inside the helmet, if you will. But now, technically, the bounds are wherever. It's a different thing, and we're talking about a different flavor of relationship between digital and physical. It's not quite so clear-cut anymore, where the digital ends here and the physical starts here. Now we can kind of mix them together. And anytime you're talking about a relationship, you're talking about something that's a little bit more personal and a little bit more nuanced. Like, even if you just take how much money and how much time you spend on video games, you can very, very quickly determine what people's relationship to video games is. Very, very stratified very, very quickly. You've got, mid-core, hardcore, casuals, just by graphing two stupid little variables like how much money and time they spend. And so what we're talking about here is a much deeper relationship with our digital content. And like most relationships, it's usually safe to just put it in this category because it's usually very personal and it's usually very muddled, which is exactly why this particular thing is sort of different. It's it's a new headspace that we need to get into if we're really going to capture the nuance of what we're talking about. It's a new space. There's a lot to learn. Let's sort of dive into how we're going to do this stuff. Okay, so you start with a traditional screen-based experience. You take away camera control. You take away control of the actual game world. You take away a bunch of your knowledge, and what are you left with? A huge bucket of questions, right? Like mixed reality starts to feel a little bit daunting. But the thing is that you have a computer that's actually mounted to the user with a bunch of sensors. You can now get a huge amount of contextual information, of personal information, of very naturalistic inputs that you've never had before that give you that control back so that you can still build very, very compelling experiences and not have to rely on all of your tool sets from the past. Things like head pose definitely give you a position in space as to where the user is, but it also gives you a bunch of other things. If I'm capturing head pose moving like this, I can say yes and no and all kinds of other head-based gestures. I can actually get the user's heartbeat directly from head pose because it actually has to be that accurate in order to remain jitter-free. I can get whether you're standing, whether you're sitting, whether you're walking. I can even tell who it is just simply because of gait information. And lastly, I can start to get nonverbal communication out of it. So if a character is talking to me and he asks me a question, if I lean forward, it might be because I'm very interested in what he has to say. If I lean forward like this, it might be that he can't hear me, and he's asking for me to repeat myself by just doing this. All kinds of like nonverbal cues that people use when they talk to each other, we can now pick up on because we have a device with sensors mounted directly to the user. I can get some level of hand input from the system. We can again do just gestures like I'm thumbs up, I'm thumbs down. We can get some level of hand tracking, but we can also determine that I'm in a particular mode of speech, and a lot of this hand gesture might be just, again, extra communication cues that we can kind of ignore, or that the AI can kind of like react to. If you're a very sort of handsy person, the AI could react to that. Eye gaze data is a very, very exciting new input. In VR, the vast majority of VR, obviously, you have what we would call a head vector, right, which sort of points forward where I'm quote unquote looking. But if I'm pointing my head this way, but I got my eyes pointing at you, like that's a lot of delta between what the system technically thinks I'm looking at and what I'm actually looking at. With eye tracking data, you can actually get the gaze vector as well as the head vector, and so you can really, really know where the user is looking, or even where they haven't looked yet. You can make use of that information to do all sorts of good contextual cues, to place hints in the right place, to kind of like lead the user where you need to. And I'll talk a little bit more on that later. And secondly, because we have cameras looking at the eyes, we can actually start to pull emotional shape data out of the eyes. You can start to get a little bit of eyebrow and then that sort of stuff, and you can get gross emotional data pulled out of that information as well. Obviously, we have voice control. We have a number of microphones, both that point inward to try and get the voice as best as it can, but also to point out so that we can have access to sounds happening in the real world. We're trying to not only generate a light field, a display technology that's aware of the depth and being able to place pixels in the right place, but also a sound field. And we want to try and get audio information based also on the shape and the textures of the room and that sort of issues. And again, I can get sentiment information out of voice. I can determine that my voice got a lot louder, or my voice got anxious, or even my breath changed over the course of time during a particular experience. And I can pull all sorts of information that I can then change the experience based on that. Head pose does register where you're standing, and all of this information can be tagged temporally as well as geographically. And what that means is I can keep large heat maps of what happened and what I've been doing while I've been moving around in my house. So like you could have an experience that takes into account that I typically feel a hell of a lot happier over in the kitchen, Or like that I'm actually quite a bit more nervous in certain areas, and so maybe don't jump scare a person when they're in those areas, because that's when they're naturally more jumpy, and you want to like be a little bit more sensitive to that. Stuff like that can kind of like, you can really start to like build pretty cool like sort of meta perceptions that the AI can kind of take care of. Like slowly over time I could learn like where my cat sits during the day, and I can steer you away from that so that you don't step on your cat accidentally. Stuff like that. So I wanted to go over some quick general design considerations, and then we'll start diving into some of the deeper AI considerations. First, less is more. I think everybody understands the concept of like, don't make stuff unless it absolutely has to be there. In mixed reality, less is more is even more important. Every pixel, as few pixels as you can use, the more magical each one of those pixels becomes. And why that is because what you want to do, again, the goal is to keep people in reality as much as possible. This reality. And if you can keep people thinking that they're in this world, but yet there's this object or this character or this thing that's in the world with you, then it feels magical. If you try to paint the whole world and splash pixels all over the place, it tends to detract from the specialness, and it tends to detract from people's ability to stay in the real world. They tend to focus on the pixels instead of the real world. The other reason that we say less is more is super important in MR is that people only have a certain amount of ability to absorb new stuff. Like in any game that you make, you only have a few minutes worth of hook to get them dragged in and teach them enough that they can start their experience with your product so that they can get that hook. There's so much new stuff in MR right now, just even the feeling of having a headset on and all of the stuff. We tend to try and keep people on the more sort of casual side of the experience, just simply so that they're not overwhelmed by everything new that they have to do, in addition to the experience newness. And so less is more is super important in MR for both of those reasons. Blended inputs are super important. Remember how I was telling you we have all of these new inputs. When I walk into a room and I ask a person, hey, there's a number of things on the table here. Which is your favorite? You're not going to just like sort of go like this and point with one finger and give me no information and just sort of point with your finger. In the old days, if I had a gamepad in my hand and the NPC asked me which one I wanted to buy, that's literally all I had, was like a directional. I basically had one little pointer, and that was all I had. But now in MR, I have the ability to respond to a number of different inputs, which are much more naturalistic and much more like what a person would do. So now if I walk into a room and I say, which one of these is your favorite? Most people will be like, I like that blue one. And they'll do all sorts of things if you watch me. They'll point with their finger, they'll look at it with their head, they'll probably look directly at it with their eyes. They might even sort of move in that direction, and then they sometimes will even verbally give me a piece of information. It says, oh, the one on the left of the thing, right? Or something. But the point is, we sort of naturally give like 6 some odd pieces of information, and now we have the ability to actually blend those all together and much more easily disambiguate targeting and activation and intent of the user. The beautiful thing about that is that when I'm dealing with another person, I can be 10 feet away and pointing 90 degrees from you, and I can say that thing over there, and even though you're not looking at me, like looking down the barrel of my finger, you can kind of tell what I'm talking about from across the room. Like that level of disambiguatory knowledge is why we do all of those things, because we're used to talking to people that aren't lined up perfectly to see all this. So it's a very natural human thing for most people to give way more information than they need. And when you start using all of that blended input together, you can very easily figure out exactly what it is that they want to do. The other thing that's beautiful is that it makes the system more robust. So if one of those inputs fails because of some crazy thing in the real world, anybody that's used robots knows that like as soon as they get into the real world, things can fall apart real fast. A meshing algorithm can fail because of a shiny black object that the depth sensors didn't quite get, or a mirror has caused the IR to bounce off and make phantom geometry or some craziness. And so if I just shoot a single raycast at it, I might fail and the entire interaction can fall apart. But if I'm disambiguating with a number of things, it becomes much more robust to the vagaries of real world craziness. And the other thing that's nice is that if you are using blended inputs, you can actually make a single targeting system, let's say, where certain targets are very skill-based, meaning that I'm probably using my finger as a stronger blend weight in this particular total blend. Whereas if, while I'm pointing and doing whatever, if I look over here and there's UI elements stuck to that wall, I can just look at it with my eyes and my head and pull the trigger. I never even have to pull my hand over to do the targeting. I can just look at it, and because those targets are blended more for eyes and head, using the exact same targeting system, I can have some things feel very, very skillful and some things very, very magical, very sort of almost mind-reading. Getting your attention is something that the VR world is well used to as well. Again, I fall back to, once you start having actual eye inputs, this becomes a lot of an easier problem. Because in VR, yes, I know where you're sort of heading, but I don't exactly know what you're looking at. If you have eye tracking, you can actually know exactly what they've looked at and what they are looking at, as well as, like, have they just sort of passed over it, or have they actually dwelled on it for a while so that they actually have recognition and potentially know, in their short-term memory, they've seen that thing, as opposed to just whisked their eye past it and they maybe didn't even notice it because they were on their way somewhere else. Given that information and the fact that we can also place spatialized audio cues into the world as well, we have a number of different ways of getting people's attention. We can, like I said, we know where you're looking, so we can start something from there and move you. We can also, because we know where you're looking, we know where the edge of your vision is, and the edge of your eye, as opposed to the center of your eye. The center of your eye deals with detail and color. The edge of your eye is mostly just about motion. So if I'm looking at you, if I wiggle my fingers over here, the edge part of my eye picks up on that motion, and it's almost difficult to stop the compulsion to turn your head if the side of your eye, the periphery of your eye, sees a motion cue. That's one of the reasons why magicians will put their hand up here and then they'll wave the magic fingers. What they're actually doing is tricking that part of your eye into almost forcing your head over there so that they can palm the whatever it is, and then they look back and it's gone. And finally, we are in reality, real reality. And so, if I go back to my original example, instead of going and seeing a movie, if I'm going over to your house, I don't do the same things. If I'm bringing you to the theater to watch my play, I expect kind of you to be a good citizen at my play. But if I'm coming over to your house for a dinner party, then you kind of expect me to be a good citizen. This is your house, right? And so part of the considerations that you have to do when you're dealing with mixed reality experiences is that you're in their world. And so you have to be a little bit more of a good citizen. You have to remember that they still need to function in reality. And so you want to make sure that you haven't taken up all of their attention. You haven't given them so many tasks that they can't actually do anything in reality. If the experience sort of expects them to walk around the office or the room, and it's a cluttered room or something, they're going to need a chunk of their brain in order to do that task well, or they're going to fall down. If you start putting a bunch of stuff up on the ceiling and you expect them to move around, obviously they can't be looking down here, especially if it's a Twitch-based sort of thing. There's all sorts of little common rules of again, being a good citizen that you should take into account here. If the experience is going and the phone rings or a human comes in and starts talking to the other person, it would be nice if the experience sort of picked up on that and maybe paused or quieted down, or maybe even just moved off to the side so it wasn't just directly superimposed in front of the person and they can't see. If I start to walk, it might be nice to get the heck out of my way again so that I can see when I'm walking forward. All sorts of things like that. And lastly, when you have a limited FOV, if you start to fill that FOV with pixels, very quickly the brain slips into what I call screen mode, which is that I suddenly look like I have a screen floating in front of me instead of pixels in the real world. It doesn't matter how beautiful they're blended into the world or whatever. If they're mostly filling the FOV on a limited FOV, you end up what looks like, to your brain, a screen floating out in front of you. And our brain has been staring at screens for years and years and years. We actually are very, very cognizant of what a screen means as humans, right? We've associated screens with a large, high-output device that just sits there, and I should center up on it and get the information that I need to get. And that's exactly what we see in MR. You can have a very realistic experience where people are moving around a lot, and then suddenly something happens, and their brain switches over to screen mode, and they just stop moving. They stop moving because their brain thinks they're suddenly looking at a TV, even at a subconscious level. I actually have hypothesized that this is one of the reasons why when the Wii first came out and they started making, or even the Kinect, they started making motion-based games, and people were like, oh, you know, people don't really like motion controls. They just want to sit in the couch. And I don't think that's actually the case. I don't think people are actually lazy. I think that they have associated sitting in front of a TV with lazy time. It's not that they're lazy, it's that watching a television means not moving. I've played hours of Audio Shield or other VR titles, and it never once occurred to me that I wanted to sit still while I was doing it. You know, like it didn't feel like a TV. In fact, we've actually done some early tests where in VR, if you show a large television, people stop moving. Right? It's not the limited FOV. It's the I think I'm looking at a TV.
Cool. All right, so Brian dived into a lot of the very low level, how our inputs work. Like he was saying, it's no longer just about building experience where you give a game controller to the user and all they have are all these buttons, which honestly, like my mother and grandmother have never been able to understand and have never played any of my video games, where now we have this crazy amount of inputs, a lot of them being natural inputs from my eyes to where I'm walking. Now what do we do with all of this? So for the next part of this, we're going to be focusing on what we call the more high-level AI side of things, where we'll be talking about environments, characters, and storytelling for mixed reality. So basically, the environment around you really plays a very important role when developing mixed reality experiences, but it's very different to how you would develop a typical video game. Normally, when we worked on games, step one is you get together with your team and you start discussing what is the world going to be. So if I'm building Assassin's Creed and we go, it's going to set place in Italy. And then you decide, all right, how does everything support Italy? But that's not the case anymore for mixed reality. Really, what we're doing by scanning the environment is we're giving you information about the context of the world that you're in, and you have to make sure that your experiences can work in any type of environment. So at someone's home, or in someone's bedroom, or in someone's kitchen. So it's a very different way of thinking when building your mixed reality experiences. And the world around you should really be the one that is telling the story. So part of doing that means you have to start thinking about, well, what would your game ingredients in your experience be? Yes, you would probably still be designing game ingredients that are specific to your experience, that are digital, but you also really want it to be so that every real-world object that we are detecting can potentially also be a game ingredient. So let's say I've detected that there is a chair. I want that chair to send off a stimuli so that digital characters actually get attracted to that chair. That chair has information about how can that character turn around and then sit on that chair. If a character is running around, does it know that that chair is there and it can jump on it to try and like escape me? Maybe you also have this old chest that exists in your living room. It's exciting to think about how maybe old objects that have been there forever, that people don't even realize exist in that world, become kind of magical. So you could think about, we're exposing to you saying that there is this chest, and that experience decides, you know what, the properties of this chest is that it glows. The properties are also that as the user gets closer and closer to the chest, it starts glowing even more. And then when I actually open that chest, maybe there's a portal or a bunch of information that floods into my world. So how do we actually do all of this for mixed reality? So one, through our spatial computing technology, we're able to actually scan in real time the environment around you. So from your chairs, to the table, to the walls, to when someone actually walks into your living room, or if my cat runs across the room, we're able to scan and provide the developers with all of this information. What we do with that is then we use all of that through our meshing and planes to be able to anchor information into the world, and so that characters can actually navigate the space. Now, since your world is constantly changing, developers will definitely want to be using digital nav mesh approach, or a dynamic nav mesh approach, rather than a static nav mesh. Basically, you don't know when someone is going to walk into the room. You don't know if someone is going to pick up a box or move a table around. So developers have to really be using this dynamic nav mesh approach. Of course, that's for when you want to actually have content that is stuck or interacts with the nav mesh, but also something that's interesting that we're exposing is what is all of the free space around you. You might have characters or airplanes or something that is flying around, and we want to be able to expose to AI developers how you can navigate on both this dynamic moving nav mesh, but also take advantage of the free space around you. So navigating, though, isn't the only way to be interacting with your space. We need to think about how do you actually interact with those real-world objects, with those ingredients. So that's where we want to be able to set affordances and see what are those smart objects that exist in the world. Through these smart objects like the chair or like the table or like even the clock that exists on my world, we're able to get information that the developers can set to say what happens or what are the properties about those specific objects. What are the emitters that are sent off so that the digital characters can actually interact with those objects. We then use semantics through objects and image recognition to be able to actually identify where are you in your world. If I walk into a room and through my image recognition I see a bunch of KitchenAid logos, there's a good chance that means that I am in a kitchen at this point. If I walk into another area and my object recognizer actually determines that there are a lot of desks, there's a good chance that I am in an office. And you want to be able to use all of this information so that even if I use experience A, it's going to react very differently to if I am in a kitchen versus if I'm in an office. Maybe my digital character that I've been interacting with for a long time feels really safe in my bedroom, but the minute I load the experience in the kitchen, it starts getting very scared, going, what are all of these machines here? So you want to use the context about the environment that you're in to influence how your digital content is going to react. And then finally, terrain analysis. This is something that both Brian and my team, we've been working on a lot. Through the meshing planes, through semantics, we get a whole lot of information about the world around us. And this can be a whole lot for developers to process. So what we're doing is basically creating a lot of toolkits to be able to tell the user, here is all the navigable areas that exist in my room. Here are the large open area spaces so that you can have characters that fly around. Or by scanning the room, knowing here's all the areas that are currently occluded by the character. So maybe you want to treat those as hiding spots, where characters spawn behind the TV or they spawn behind the table, and then they peer out from behind. So what we're trying to do is, with our AI experience, build lots more of these terrain analysis tools to be able to allow developers to take advantage of the space around them. So now what about characters? As Brian mentioned earlier, less is more, and probably some of the best moments we've had when designing content for mixed reality is when it's just me and the character alone, and we're actually having this great adventure together versus tons of crazy things happening around me. But working on a world that is ever-changing is also a real challenge for character AI. One thing that whenever we sit down with partners and we start talking about designing character AI for mixed reality, we start talking to them about the uncanny valley. And it's not the uncanny valley that everyone is used to, because it's kind of a solved problem now where we actually do have really beautiful high-res looking character models, characters that have beautiful animations, characters that look real. What we tell our developers is actually that the new uncanny valley is going to be when characters exist in your space and where they don't react to what is happening around them. Another challenge is really on the animation system side of things for characters. In video games, I remember a couple of years ago on Assassin's Creed, we had said, we're going to make an Assassin's Creed that has 0 metrics. We're going to make it so that the level designers can build anything, and we will support animation for whatever through procedural animation. And that was kind of hell. That's crazy. As game developers, we are very used to the process of saying, all right, level designers, these are our clear metrics that we are giving you. From there, we can build what the behavior system is, and then figure out what the animations are that need to be supported. But we're in a new state now where we don't know where our experiences are going to be played. It could happen in this room. It could happen where the table in your living room versus the table in your living room is very different. So building procedural animation systems is also going to be a huge challenge. So how do we do this? So most of us in game AI have worked on very large amounts of data and had to build huge perception systems to handle this. But now we have a lot more inputs. Like Brian was saying, we have eye gaze, we have movement from the character, we even know, are they stressed based off of their breathing? And we need to start thinking about how do we actually organize all of this information in large perception systems that truly do react to all the stimuli around them. I remember when every game that I worked on, we would start designing what the AI system would be, and it would never be a question about do we use behavior trees or something else. It was always behavior trees. And I always wondered, because when Fear came out, they had this really great talk about, hey, we decided to use AI planners for this. Yet a lot of large games never use AI planners. We've only started to see AI planners be used recently, more for games that are procedural. And a lot of the indie game space are using planners as well. And this is something where we're trying to tell developers, the behavior tree system, you could use this for certain things where you really want your characters to be relatively scripted. But because your characters, you want them to grow, evolve over time, and truly react to the world that is constantly changing, AI planners, GOP, HTN is going to be something that we're going to be seeing a lot more of for AI developers. Behaviors as well. So this is where, based off of all of this stimuli, where we will hopefully solve this new uncanny valley. Basically, if you have a digital character that is interacting with you, and all of a sudden we detect that a glass broke in the room next to you and the character doesn't react to that, it's going to feel really broken. So that's really where the behavior should be, yes, what are the goals of the characters, make sure that they're trying to accomplish those goals, but where the stimuli coming in from what is the sound that is detected, where is the user actually looking at the player, all of that should be used to make sure that the characters react accordingly. If I have a digital character that is over here and I decide to walk away, the minute that digital character tells me, oh what, I'm not interesting enough? How come you're not looking at me right now? That's when you're going to go, this feels really real. So you want to make sure that you're designing your systems where all the stimuli are used to make sure that you have characters that react. Now on the animation side, as I mentioned, like procedural animation is going to be huge. I think we still need to keep pushing on this. This is not a solved problem. A lot of the indie games have been pushing a lot to create truly believable, amazing procedural animation systems. But something that we've been telling developers is start planning for your fail states. Basically, if you have an AI system where the character gets to the edge of a table, does a check to see, can I actually jump from the table to the ground, and the animation system says, no, I don't have the supported animation. Some of the great moments is where that character should look up to the player and go, do you mind bringing a chair a little bit closer to me? So really designing around, if this system is not supported to be able to do something, get the player to do something so that the player can navigate. Maybe it is a large-scale character that is trying to walk to a certain space in your area. Maybe the digital character should stop and say, there's a chair in my way. You mind moving it for me? And that's really where it's going to feel like not only are you playing this game, but you are part of it. You are interacting with the experience. And then finally, deep learning through our image recognition and object recognition. I think the most obvious that we've seen developers want to do is once they know that there is a Pepsi can or a Starbucks cup, that the characters would be aware of it and be able to interact with it. What we also want to see is when you detect certain objects that those maybe become characters. Maybe you detect that there is a teapot, and that teapot becomes Mrs. Potts from Beauty and the Beast. Or you detect that there is actually a picture frame over here. In that picture frame, you render a moving image just like in Harry Potter. So we want to see developers not only use image recognition and object recognition just for characters to have awareness about the space, but also use those as potential characters in the world. Now finally, for storytelling and narrative design, one of the first things that we saw when we started working with partners is there were two types of stories that were told. I think the most obvious that we've seen, and this is even on different platforms, is tabletop storytelling. It's something that's easy. It's really where you are using one object in the space, and you can have everything play out on that one area. Another area that we've been starting to push developers to use is also portals. I think in video games, we always found that how do I spawn something and not have it pop right in front of the player? It's really jarring, it doesn't feel right. And portals are actually great. We've had it where we have portals that spawn on top of the user, and you slowly start to see it open with things falling. And naturally, people just kind of fall to the ground, or they try and get out of the way of this opening portal. So using portals is a way to either get the character to move around or to get them to be attracted to a certain space. But the area of storytelling that we really want to see developers push more of is building a relationship with characters that changes over time. This is where we've seen that in traditional video games, the verbs that tend to keep coming up is shooting, killing, fighting, and I think with every content partner that we have worked with, because this is characters in your home, just like as you were talking about George Clooney being in your real home, it's about trust and relationship in your home. And I love how a lot of the verbs that are coming out from this is really friendship and bonding, and how do I build that trust? But also thinking about how does the narrative with these characters change over time? And this is where we think that also pushing on the AI side will help us build these long-term narratives.
Obviously, designing for narratives is tough, even in the screen-based world. Like, the beautiful thing about our device and this new genre, or this new medium, is the set of naturalistic inputs that you get to try and help fix some of the problems of designing for narrative. Like, obviously, again, we go back to planning, because anytime you're talking about an extended narrative, you're talking about planning to get there. Unless it's completely scripted out, you kind of have to plan how you're going to get there. And whether it's a particular story note that you want to hit out in the distance, you know, several players in a scenario, several roles need to get lined up in a specific way so that now you can hit the next story beat and move to the next, in the next direction that you want your experience to go. Or whether you're just talking about a specific experience that follows a particular social practice. Like, by social practice, I mean, am I having a conversation that's literally an interrogation, where my goal is to pull some piece of information out of you that you may or may not be willing to give up? Or is the reason that this interaction is happening because I just want to build trust with you. I want to, like, find common ground, see if there's any sort of chemistry between us, and I want to, like, become friends with you or something like that. Those are very, very different goals, and I have to, like, take all of the inputs that you're giving me and plan for how I want to get there, try and get around the thing. Obviously, if you are doing that, we're talking about procedural narrative, we're talking about conversations or stories that can morph over time and that need to basically fill in the bits between the story beats. So you're going to take all of your inputs and try and push procedurally to get where you need to go. And usually when you're talking about conversations or procedural systems, what you want to do is let people actually interact with that in the most natural way possible, which is usually voice if it is a conversation. And if that's the case, you're going to need natural language understanding to try and let people use that as an input. Obviously, that's a tough place. The AI systems that are starting to show up out there for all of our use are getting better and better, and being able to tie all of the rest of the inputs that the system has into that text stream, into that temporal text stream, so that they can start to see the emotional content and that sort of thing, will actually help with the NLU quite a bit. And again, like I said, we use deep learning here too, because we have deep data systems that can start to really deeply model the player, his intent, as well as, like, what direction you want to take the story. So if you're kind of like the AI director sort of notion, where the part of the player model could be like the types of information that this particular user learns well or doesn't learn at all, the types of things that they really don't like. If you've determined over time that a user is full-blown phobic with something, then maybe don't use that as a main character or something. And finally, because we're talking so much proceduralism, you have to start getting your systems be okay with a little bit of emergence. You have to also teach your designers to be okay with a little bit of emergence. Yes, they can have authored story beats that they head towards, but they need to be able to like absorb the squishy bits in the middle that like allow your story to flex and actually be more interactive. You don't want to get too emergent, obviously, or you end up with the Westworld scenario. So why did we come to Magic Leap? Why are we so interested in this medium? Why do we love it so much? And the reason why is because over the last 4 years, I've actually, like the team that I've worked on has probably pushed, I don't want to know, 5, 6 or more 100 prototypes over these last years. And every single vertical that we hit, whether it's gaming or productivity or collaboration or medicine or educational stuff, everything we find, we have found it to be enabling. We have found it to be kind of a novel thing that actually gets more engagement. It's a breath of fresh air in every direction that we take it. And we've been wonderfully excited by every new experience that we find that works really well. And we've never yet had a thing that's been bad. I mean, we definitely, like Aleissia was saying at the start, we have definitely said, you know what, this is okay, but it's still better in VR. This is still the VR world, right? And so like just because we all have 100-inch televisions in our homes doesn't mean that occasionally we don't want to go watch an IMAX theater, right? Experience, right? Like that still exists, and that's a good thing. It's good to have different tools for different jobs. But this particular tool we have found to be pretty damn effective in many, many different ways. And so, as far as we're concerned, it's a huge new space. It's a massive new world, and we haven't had that for a really long time, especially in games. We've been doing variants on first-person shooters now for what seems like 20-some years, and it's really starting to get a little bit stale. And what we have found here is not just new places to play the same genres, but new genres, new ways of experiencing things, and new ways of interacting, not only with our digital stuff, but with each other. One of the things that's been truly awesome to find is that anytime we have a shared experience with other people, when people are directly manipulating and sharing digital pixels in the real world, it's almost always a magical experience. It's kind of funny because if you see some crazy little critter run across your floor, the first thing you're going to do is like look at somebody and go, "Did you see that?" And if they say, "Heck yeah, I saw that," it makes it that much more real. So there's a sort of human-to-human confirmation that makes MR feel that much more real. But at the same time, it's so novel and so wonderful to like directly be able to manipulate magical stuff with the person next to you, that whether we're playing a game or we're working in chemistry class, like the sharing of that digital stuff makes that much more engaging and that much more sort of present.
And I guess since we both speak together at these conferences, we're both interaction directors. And I think one of the things that we're really excited about is how can we make any place that I go to, any like mundane activity that I'm doing every day in my life become more interactive. One of, I think, the verbs that we really want to see more of that developers embrace is really the idea of role-playing. And when we were growing up as kids, you would go out into the backyard, you would pick up a stick, you would be like, "This is my sword." And you and your friends, it would be about getting together and role-playing. But we don't do that anymore as adults. And maybe it's because we lose a lot of that imagination. And a lot of us are game developers because we do love sitting down and getting to play a role with a character that's on screen. What we would love to see is get more and more developers figure out how can we bring all of that amazing interaction and play that we get in our video games that are on screens and bring it to the life around us. Maybe even when I get into an Uber or a Lyft or on a bus, I actually walk onto the bus and it's like beep, 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 beep. You are now playing this role. I want to have it so that anything that I'm doing becomes fun, and where play becomes something that is part of our everyday lives, not just with what's on screen in front of me. Thank you.
Hello, I've got so many questions, but I'll narrow it down just to one for now,
Okay.
which is I recently saw Patrick Wagner from Weta, head of Interactive at Weta, talk, and he showed like a teaser trailer of an experience where like the walls were breaking down and creatures were coming in and people were like shooting and the rest of it. We recently had our first VR death from somebody who fell through their glass coffee table and didn't realize they were bleeding to death over in Russia. What are you guys doing to stop that happening?
Well, I mean, that's, like I said, I actually had an entire slide on, like, you know, just making sure people can stay in the real world. Like, we recognize that, like, completely erasing the reality of the situation is potentially problematic in certain circumstances. I think that even in VR, they've gotten a lot better with chaperone systems. I remember when the Vive first came out and it told you where the walls are, and before that, you know, GDC was done, they said, I had somebody from Vive tell me that they were already working on dog detectors, because a lot of times people would put the helmet on and the dog would come walking up to them and sit right there. And it was like, yeah, it's playtime. And then they would, you know what I mean? So even the VR people are working on that, and like I said, we very specifically are trying to get people to understand that the best experiences in MR are where the real world is one of the primary actors, and it's really difficult to get in that level of danger if you follow those guidelines.
Yeah, the less is more, and that's where we've seen from working over the years with partners, when it was just like, put all the information, and we're like, no, that's not safe. You need to have it so that there is a few objects, and also where the objects are rooted to the reality around you. I remember I'd gone in and I demoed a project, and it was a bunch of beautiful trees and things, but they were just floating there. And I'm like, you realize I tripped over the table. I'm like, you need to have it so that the trees, like, you are aware about where is the floor areas, where are the open floor areas that have at least X meters for the user to walk from here to there. And that's where we're trying to make sure that we provide those like terrain analysis tools, so that it's not just people that are like spawn stuff all over the world around you. So we really want to make sure that we're providing those tools where it does take into consideration safety for the user.
We're even working on ways that that developers can like kind of measure particular experiences, like how much information they're asking of the user at any given time, so that you can kind of budget, like, hey, I know that I'm making a very casual experience, and I know that I'm going to ask them to be walking around, so I can kind of limit the bandwidth that I'm asking of them, CPU-wise, you know, so that they have enough left over that you can essentially let them budget enough to be safe.
Great. So my question is about multi-users, and what are the limits currently on games that could have 5v5, 12v12, and what are the spaces? What is the size of rooms that you can use, and can they be outdoors and indoors, or mostly is it all an indoor experience? And finally, what's the refresh rate? How quickly does the dynamic meshing change, so that, you know, if you've got 5 people on 5 people, how quickly can the system react to that?
So there's a few points there. Let me see if I can get through them. For product one, we are mostly working on an indoor device. I think we're calling it outdoor adjacent, because we can kind of go outdoor-ish. Like, the thing is if you only have so much light that you can add to the scene, outdoors you have about 10 to 20 times the amount of ambient light. And so if you can only add so much light to a particular scene, outdoors you have to be able to add 10 to 20 times more light in order to have the same level of brightness outside. That's why we're sort of focusing right now, because we're trying to get good battery life, we're trying to blah, blah, blah. Anyway, so for product one, that's what our focus was directly. That being said, like the size, we have block-based mesh, so like it's almost like an MMO. Like when you go to the next chunk of the MMO, it loads the new stuff and archives the old.
It's stitching everything together, and that's what allows us to have the real-time scanning. So it is doing block by block, and as you move around this space, it's just stitching everything together. But it means that if I walked all the way over there and I came back here, I would still have that mesh that had been scanned.
Now, that being said, the entire meshing system, including some of the refresh rate, the block size is somewhat parametrical. So like if you know you're going to be making an experience in a single room, you can kind of tune things a little bit so that you get higher performance that way. Where if you know you're going to be in a giant, multi-room, 3-story craziness, then you can tune things a little bit more differently there so that you get maybe a little bit more refresh and a little bit more space, right? And so it's usable by the application directly to try and tune the thing the way they need it. Now, how many users? That is more of a network question, right? Like our device doesn't really necessarily limit the number of users. So like in exactly the same way, if you want something to be fairly reactive, like a first-person shooter type of thing, you limit the number of users so that the amount of cross data can get there at a nice high refresh rate. If it's a little bit more asymmetrical, you can have hundreds of users, just like you do in an MMO, right? Because like that's not quite as latency bound as a shooter is, right?
Yeah, it's just like we said, it has nothing to do with our platform. The way you design your network, whether you're on Unity or on Unreal, it's purely the limitations of your engine that you choose. You want to build an experience that's 100 people connected? Great.
But you're going to incur that network latency just like you would in a screen-based experience.
Hi, thank you for the presentation. I had a question about there's a lot of user data about their home, about the way they are looking, their heartbeat, the scanning. How is privacy handled in this?
So that's another thing that we spend a lot of time on. We actually have an entire team of Israelis who are dangerously close to delirious security nuts, like focused on the security of the system. So yeah. We've done everything from certain inputs never actually get down to the belt pack where they can potentially be wirelessly sniffed, like they're consumed directly by the headset so that they never get out to the outside world, all the way till anything that is being sent up, like some geography information that's being sent up is very specifically encoded in the whole 9 yards and very, very safe. We right from the start have always held the position that you own all of your data and that is for you to decide what you want to do with.
Yes, just to give, I guess, a concrete example, like when we were talking about the eye gaze, we know that under the hood there's a whole lot of information from like your saccades, how quick you blink, like how often do you look at something, but what's exposed to the user is really where are you looking? And maybe as we go with the future, we'll end up seeing like, let's expose more and more things, but we've been very, very conscious about let's make sure we keep security in play just in case like some of that raw data could be used in ways that we didn't expect it. So we are trying to not expose a lot of that raw data, even though occasionally us as developers are like, damn it, we would love to have this. And I think once it's out there and developers go, we really want to have A, B, C, then we'll be able to get that feedback and see what more can we expose that wouldn't cause a security concern.
I mean, even over the course of the time that I have been at Magic Leap, we've gone from a softening, in America at least, I don't know about in the UK, but in America where when the Google Glass first came out, people were very concerned with being recorded or whatever, whereas now in America, like the vast majority of police officers have a body cam on them, and people are starting to wear their own body cams, and so there's like less of a concern about recording and more about like, where's mine? And so we're seeing, sort of the universe change as well, and we're trying to be very cognizant of it, but at the same time we need to be able to support what the community wants.
Thanks, Aleissia and Brian. Those are awesome.